All right, we are now moving on to problem number 7. And problem number 7 is this issue of using a linear model to answer questions about a particular physical system. So the physical system here is that we have some trees growing on a mountain side. That's how I think of it. And somebody notices that at the 1,000-foot elevation, this is elevation, that the typical tree height is 90 feet. But then they hike up to the 9,000-foot elevation, and the trees are only 10 feet tall. So that's 2 points, 2 data points. And if you want to think graphically, which I encourage you to do, is you've got a situation where this is elevation, and this is the tree height. And what we're saying is that somebody made a measurement at 1,000 feet, and another measurement at 9,000 feet, and at 1,000 feet they got 90-foot height, and at 9,000 feet they got a 10-foot. Backwards. 90 feet is right here, and 10 feet is right here. So somebody made a couple of measurements, and now the issue is, can you model that algebraically to be able to tell lots of different things about that system? So there are these 2 data points, and you want to write them in point form. So one point is 1,090, and the other point is 9,010. Right? Those are the 2 points. And here you can see them right here. This is your 1,000, 90, and this is your 9,000, 10. Okay. So everyone did very, very well on this. They were able to go from the little table to the point form. Okay. Everyone did well on that.
On A?
Yeah, on part A. Everyone did well on that. Okay, now, write an equation for the tree height versus the elevation in point form. Well, the way that works is y minus y0 equals a slope, which is, rise over run. So the rise is y1 minus y0, and the run is x1 minus x0, and this is equal to x minus x0. That's point form. Okay. So now we just got to plug in the numbers. Let's do this. This is x0, y0, x1, y1. Okay. So y minus y0 is y minus 90 equals, okay, y1 minus y0, well, that's 10 minus 90, divided by x1 minus x0, well, that's 9,000
Minus 1,000.
minus 1,000. And x minus x0, well, that's x minus 1,000. Okay, so now it's just a matter of, the only thing we really have to do is reduce this to a nice number. Well, y minus 90 equals, looks to me like that's minus 80 over 8,000. Right? Okay. Did I get that right? That's minus 80 and that's 8,000.
I didn't get that far.
Okay. So, but minus 80 over 8,000 is minus 1 over 100. So y minus 90 is equal to 1 over 100, minus 1 over 100, x minus 1,000. Now, this thing right here is the slope. Right? Because at this point, we've gone from point form to point slope form, actually. And this should make some sense to you. The slope is negative. Very important. Because you see that as you go higher in elevation, the trees get shorter and shorter and shorter. So we know the slope is negative, which is very good. So that's part B.
That was part C.
Right, now, yes, and part C. Show that the equation step B, simplify the equation step B and show that the equation in slope-intercept form. Okay, well, we've got to take this and put this in slope-intercept form. Well, all I have to do is put the 90 on the other side. Watch carefully. Y, well, let me rewrite this. Y minus 90 equals minus 1 over 100, x minus 1,000. Okay, well, how about if I put the 90 on the other side? X minus 1,000 plus 90. And now let me simplify, or carry through to get rid of this parentheses. Minus x over 100. Oh, I'm good there. And this is plus, and what is this? 1,000 divided by 100, that's 10. And so I end up with minus x over 100 plus 100. And I even tell you what it should be. You've just proven that, yes, y is equal to minus x over 100 plus 100. So that means x is the elevation and y is the height. Let's see if that conforms to the data. We said that when x is equal to 1,000, the height was 90, right? Let's just see what happens if we say y of 100, 1,000, is equal to minus 1,000 over 100 plus 100. Well, that's minus 10 plus 100. Yep, that's 90 feet. So at 1,000 feet, the height of the trees are 90 feet. Well, what about at the 9,000 foot level? Well, that would be minus 9,000 over 100 plus 100, which is minus 90 plus 100, which is 10 feet. Perfect.
So, I'm sorry, so C was just what you had written there, y equals x over 100 plus 100.
Right, I wanted to see that you could go from here, from the point form.
Oh, how to get there.
Yeah.
I see.
Right, I wanted to see the work where you can say, okay, I'm going to simplify this and put things on the, run through the parentheses and put everything on the appropriate side so that you come up with a y equals mx plus b
Okay.
form, and you always can.
Okay.
Okay. So now we come to the D question. What is the effect on tree height when the elevation is increased by 1,000 feet?
Wouldn't you just do that? Y plus 1,000? Or y times 1,000?
Not y times 1,000. What is the effect on elevation, or what is the effect on tree height when you change the elevation 1,000 feet? Well, you know the slope. The slope equals minus 100. That means for every 1,000 feet, you're going to drop 10 feet in height. Isn't that what that means? Minus 100? This means this is the change in tree height divided by the change in elevation. That's what the slope is on this. Remember, we looked at that. We looked at this graph. Here's the slope, and there's so much change in tree height for every change in elevation. Right? So when I say the slope is minus 100, it means that when I change the elevation 1,000 feet, you multiply that by the slope, and you get the change in the tree height. That's what slope is. How much change in one variable for change in another variable. Okay. Oh, what's the tree height at sea level? What does that mean? What does it mean to be at sea level?
Zero?
What is zero?
Sea level.
Yes. But which variable is zero? X.
X's?
X is the elevation. See? Elevation. This is X and Y. Y. So at sea level, x is equal to 0. So that would tell you that the tree height at sea level is 100 feet.
How could it be 100 feet if it's 0?
The elevation is 0.
The
elevation
If the
0.
elevation is 0,
Oh, plus 100.
you're here on the graph, and you're at the 100-foot, you're 100 feet in height. We're using feet now, and maybe that's what's confusing. We talk about elevation in feet and tree height in feet. But if the elevation is 0, you're at sea level, then the tree height is 100 feet.
And did we go over this? Did we have this on somewhere in
This
our,
was the plant drawing.
the plant growing one? Is it similar to the
It's
plant
very
growing
similar.
one?
That was plant height versus time. This is plant height versus elevation.
Yeah. So that's confusing.
Then we go to, at what elevation does the tree cease to exist? What does that mean, the tree height, and I even say so, the height at which the timber line is where the tree height is. They don't grow anymore. The height is basically 0. So so in this y equals mx plus b equation, what do I set equal to 0? Y. That's the tree height. So if the tree height is 0, then we can solve for x.
Did anyone get all of this?
No. So let me move that over to the other side. So minus 100 is equal to minus x.
What?
I technically got all this right,
Did you get it over?
but all this, yeah.
Oh, I thought no one did, but you got it over. Okay,
Except that, I misplaced the first point notation at the top.
Bravo! You.
Okay.
You're the only one though. huh?
all right, so I plugged in 0 for the tree height and put the 100 over on the other side. So now I've got minus 100 equals minus x plus over 100. So that's 100 equals x over 100. So x is equal to 100 times 100, which is 10,000 feet. That's the tree line, the timber line. Well, what is that on the graph? All I'm asking is, where's the intercept with the x-axis? The first question is, where does it intercept the y-axis? The second question is, where does it intercept the x-axis?
Maybe it would have been helpful to have a graph done on here to try to figure it out.
Graph on your scratch paper.
You can make your own graph.
Yeah.
I encourage that.
Well, yeah, I mean, I didn't even have time to finish it because I didn't get that far.
Okay, and the last part of the question was, how tall are trees at 5,000 feet? What do I set to 5,000 in this y equals mx plus x? So y equals minus 5,000 feet over 100 plus 100. And that's what, minus 50 plus 100 equals 50 feet. So at the 5,000 foot level, right here, they're 50 feet. Okay, so that's question 7. And I do want to say, I want to make sure everyone understands that I think this technique is so important. You use it so frequently in all forms of science, economics, business management. I can't think of a single area of endeavor where linear modeling is not used or is not important. It is very important. That I'm pretty sure that on the next midterm I'll have something that is, again, 2 data points and then tell me about y equals mx plus b. Given those 2 points, I want to know about y equals mx plus b, and I want to know what happens when x is 0, I want to know what happens when y is equal to 0. So you can handle
Well,
this.
you have to go over that then, so that people are more, because there's so much information, and there's so little time, that if you go over it once or twice, then it's,
Okay.
it needs to be gone over, saying that this is really, just there's just so much information, it's like what's important, what's the most important, what's not, as important maybe, or whatever. I don't know, I file it, there's a lot of information.
We will have
There's so much
review.
information.
Yeah, we'll have.
So maybe have something in detail like this with the example, so people
Okay.
can look at all the steps, and
Okay.
that would be helpful.
All right, and on the
Especially
practice,
that we got
on
it.
the practice exam, you'll have another one of these things.
That's what I mean, the practice exam,
Yeah.
do that, and then
Yeah.
have it broken out so that people know, the different parts, like A, B, C, and D, so that people can try to go and figure it out, and then,
Okay.
that would be helpful.
Okay. Let's do problem 8. Okay, so here I'm going to show you some matrices that are in row echelon form. And I just want to know, I don't want to know the solution. I just want to know, is there a solution? Is it unique or is it infinite? Okay, so here we go. Let's take a look at the first matrix. It's an augmented matrix, but it's in row echelon form. Okay, now, it's in row echelon form because I have diagonals of 1s and then 0s in the lower triangle. And you'll notice I had 4 checkboxes. No solution, unique solution, infinite number of solution, and number of solutions cannot be determined. What can you rule out immediately? Right.
I'm sorry, what was that?
The number of solutions cannot be determined. I have never said that once you have a system of linear equations, you can determine the number of solutions. There's no such thing as, I can't determine the number of solutions. So that was a giveaway that you just don't do that. So it's got to be either no solution, a unique solution, or an infinite number of solutions. So I look at this, and what do I need to know that this is a unique solution? I know this is a unique solution because it's consistent. I know it's consistent because I have a 1 in this at this element, which tells me that the z component is -1. The z variable is equal to -1. So, and then if you can back plug in and you can get whatever the solution is. There's the, yes.
The z's always going to be that last.
Yeah, this is the x column.
X, Y, Z.
Y and Z, or A, B, C, or whatever your variable names are.
So that didn't make sense. Can you explain that further? Why? Just because it's the Z is why it's a unique solution?
Okay, because clearly Z has a value.
Because 1 equals -1, it says that. That's
Because
what
Z equals -1.
Right, well, Z.
Not
1Z.
one.
Well, 1Z.
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 Right,
equals-
Jane.
Yes.
1Z equals,
1Z
so I know there's a value of Z. Well, if there's a value of Z, I can plug that in here, and that tells me the value of Y. I don't have to go through the arithmetic, but I know, okay, that'll give me the value of Y, and therefore I can work my way up to the value of X, which is something times the value of Y plus something times the value of Z, and that's just 0. So that this has a nice solution.
Yeah, but why would it not be an infinite number of solutions?
I'll show you why in a moment.
Okay.
I'll show you why in a moment. Let's look at the second one. You'll see there's only certain classifications of these matrices that break down into one of the 3 possibilities. So here, 1, -1, 2, that's the same row, same column, same row. 0, 1, -1, and 3. But here, I've got 0, 0, 0, and -1. Okay, it's the same it's the same row echelon form as the first matrix, but it's for a different linear system, and it works out to have this form. Now, I ask you, can that have a solution? No.
Because 0 cannot equal 1.
0x plus 0y plus 0z is equal to -1.
So so you're looking at it's just the bottom line.
Yeah, that's enough to know.
Just enough to know. So plus if you just see 0, the Z, 0 cannot, right, 0 on the Z.
Well, it's 0x plus 0y plus 0z is equal to -1. There's no x, y, z I can think of that will make that true.
Okay.
So the first example was unique solution. This was no solution. Okay. So when you see a situation where you have a row of zeros and a value there that's not 0, that can't be. Okay. Now the last example is probably the same thing. -1, 1 minus 1, 2 and 0. 0, 1 minus 1 and 3. 0, 0, 0, 0 for the last row. So what is the last row telling you?
It's nothing.
Absolutely nothing.
Absolutely nothing there. But can it be,
Right,
but it can be a
right.
solution?
So, it's not that it's inconsistent, it's just that you can't determine the Z value.
Well, yeah, so you
There's
just,
there's nothing that determines the Z value. That means Z can be anything.
that can also actually be removed. Couldn't it be removed, like,
No.
because it's nothing?
No, when I say, what does this mean, and we say absolutely nothing, it means that there's no specific value of Z
Okay.
Z can be any number. And if Z can be any number, that tells you you've got an infinite number of solutions.
Because there's no Z?
Because Z can be anything. I can make Z any value, and I can calculate X and Y for that value of Z, and it will satisfy my equations.
Okay.
It will be a solution, but I have an infinite number to choose from because I have an infinite number of values of Z that I can choose from. So,
Okay, so that's the reason.
So when it's all zeros like that, it's,
all zeros is an indication that you have an infinite number of solutions.
Okay.
Always. Sometimes you might even see this. This does happen once in a while, where you have two rows of zeros. Now, you have two rows of zeros. That means Z can be anything,
And why?
and Y can be anything.
So it's still infinite.
It's also infinite.
Is there any other situations where there is X, Y, and Z, there is a value where it can be infinite?
No,
No.
no, you've got that
That's
unique
that's
solution.
unique. So if you have three and that's X, Y, and Z,
Right, if you can solve for X, Y, and Z, that's a unique solution. Remember, the only possibilities are no solution, unique solution, or infinite number of solutions. Okay. So that takes care of problems 7 and 8. So